Today we're talking about Pascal's triangle and the binomial theorem. You'll be able to use Pascal's triangle and the binomial theorem to expand equations. Okay? As you guys remember from Algebra 2 or from last year, is that Pascal's triangle had an array of ones along the edges, and then these other numbers here will represent the coefficients of your binomials as you expanded them, okay? And how do you come up with these numbers in the Pascal's triangle? Add.
Start with 1 and
the numbers above it. So 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 4 is 4, 3 plus 3 is 6, so on and so forth. So what line was this of Pascal's triangle? 0. So this is any binomial that's raised to the 0 power, because anything raised to the 0 power is 1. So this right here would be line 1. This right here would be, and so on and so forth, okay? So if you were to expand just the general binomial, x plus 1, a plus b, you would get a squared plus ab, or 2ab plus b squared. And that's where those coefficients are coming from. So our fifth line of Pascal's triangle would be what? Our sixth line would be what? 1, 6, 15, 20, 15, 6, and 1. And it continues like that for the rest of the triangle. Okay? Now, the bigger your rows get, the more challenging it becomes, because you're not going to sit there, you're not going to expand it out, do the 7th row, do the 8th row, so on and so forth. So there is a way that you can go directly to a particular row and a particular term within that particular expansion. Okay? So these numbers in Pascal's triangle can be found by doing combinations. Hopefully you guys remember that format last year. This would be used again to find a particular term inside of a row. Okay? The number of combinations in items taking are at a time. So let's say we were looking at our 20th row of Pascal's triangle, and we wanted the 13th coefficient or coefficient for the 13th term. 20 would be n, 13 would be r, and that's the formula we use to figure out what that coefficient exactly is, instead of doing out 14 more lines of Pascal's triangle. Okay? The exclamation mark stands for, anyone remember?
Yes.
It's when you do like the countdown thing.
Yeah,
5, 6 times 5 times 4 times 3.
Exactly. So what's the name of that? Factorial. Yes, so whatever that number is, you start at that number, you decrease by 1 and multiply all the way down. Okay? So that is factorial. Remember, there are shortcuts, when you are doing this. Prime example, let's take one that was already on the previous page, like, what if I wanted you to find the 3rd term in the 5th row? So that would be 5 combination 3. If I use the formula, that would be 5 factorial all over 3 factorial n minus r factorial. What would that be?
5 times 20.
5 minus 3, which is 2. Okay? And so then basically you would have this whole 5 times 4 times 3 times 2 times 1 in your numerator. You would have 3 times 2 times 1 times another 2 times 1. Those would be all your pieces. Now you don't have to actually sit there and actually have to multiply all these out, because realize that something like this could be on a non-calculator, but you should be able to recognize that since you are multiplying, what can you do? Cancel out. I have a 3, 2, 1 at the bottom, and I have a 3, 2, 1 at the top. So that leaves me with just 5 times 4, which is over 2 times 1, which is just, instead of saying they're trying to get 120 all over 6 times 2, which is 12. Let me go
5th row, 3rd term.
5th row, 3rd term would be 10. And just to double check, 5th row, 3rd term, wasn't it 10? Sure was. So it does work. So we're going to look at an example. What you guys do on your own. 8 combination 2. And after you guys do it by hand, I'll show you how to do it in the calculator if you forgot how to do it. Here we go. Alright, so you guys did 8 factorial, right?
Yeah, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
What did you put on the bottom?
2 factorial. 6 factorial.
Okay, so we have 2 times 1, and then 6 times 5 times 4 times 3 times 2 times 1, and you'll see
2 times 1 cancels.
2 times 1 cancels, but so does.
Why do it the whole that?
Now, let's just say this is a non-calculator question, right? And these weren't as, you know, I don't know, as small and nice as they are. Say this is like, I don't know, 20 and 19 or something like that, you know, super big numbers.
I mean, I'm right there.
The denominators can go into the numerator, right? 2 can go into 8 how many times? 4. And so technically you just have 4 times 7, which is over 1. So you can continue to keep simplifying, you know.
All these before fraction shortcuts that are
In your calculator, pull it out. So fresh, remember how to do this in your calculator. Alright, so here we go. How do we do this in our calculator? It's very simple. The top number, which in this example was 8, right? We go to math, we go over to PRB, or if yours like mine is PROB, and you'll see NCR. That stands for combination. N is the top number, R is the bottom number. So you type that in. Type in R. You click enter, and you get that. Now, if yours does this, when you go to NCR and it pops this up, it's fine. Just type in 2 and click enter, and you get the same thing. Okay? So if you go to math, go over to PRB and go to NCR and it does this in your calculator, all you do is type in a 2, and there's your answer. Okay? Or not 10, sorry, I'm at 28. There we go. I don't know where I got 10 from, I guess 10 plus 2. And that's how you do it in your calculator. Permutations. That is when order doesn't matter. So, the binomial theorem states that for any power of a binomial where n is an element of a natural number, in other words, n is a positive whole number, you have this right here, which is the binomial theorem. This is basically another way to expand a binomial without using Pascal's triangle. This will be more beneficial for the powers of your binomial that are high, like 10, 12, 13, so on and so forth. Because then you can basically use combinations to figure out your coefficients, okay? So whatever n is, that's your numerator, or not your numerator, that's the number at the top of your combination, and then you start at 0 and basically increase until you have the same letter, or same number inside of the combination. Your first term, exponents decrease. So whatever your first term is, you raise it to the nth power, and then you continue to decrease all the way until 0. Your second term, the exponents start at 0 and begin to increase. So this would be to the first, the second, so on and so forth. One thing you always want to make sure is that when you're doing this, take your time. The sum of your exponents should equal n. The number of terms that you'll have in your full expansion is always one more. And lastly, the coefficients, again, are from the Pascal's triangle, which you can find using combinations. Okay? So we're going to look at an example of all this all together. Okay? So we're going to expand using binomial theorem. So, first thing I'm going to ask you, how many terms am I going to have in my expansion?
6.
I'm going to have 6, because it's always one more than the actual degree. So, I'm going to have my set of combinations. My top number is always 5, and I start at 0. And I continue to increase. You guys can probably keep this all the same line. See, I don't have, space. Okay? So we increase the bottom part of the combination all the way up until I reach the exact same number as n. And then my first term, which is y, we start with n, and then we decrease by 1 our exponents. Then our second term, we start at 0 and we increase. So that's going to be a positive 3 that gets raised to the 0 power, to the first power, so on and so forth. Now it's very important that if it's a minus 3, you watch your signs. That usually tends to trip students up. And now, let's work it out. So, 5 combination 0 is 1. You have a y to the 5th, and 3 to the 0 power is 1. So there's your first term. 5 combination 1 is 5. Now we can definitely do it out, 5 factorial over 1 factorial, then 4 factorial. Or we can know the 5th row of your Pascal's triangle, or we can use our calculator, either way. Then you have a y to the 4 times 3 to the first, which is just 3. So you're going to simplify that some more to get 5 times 3, which is 15. So your next term is 15 y to the 4th. What's 5 combination 2? 10 y to the 3rd times 3 squared, which is, what's 10 times 9?
90.
So our third term is 90 y to the 3rd. And we just continue on like this. 5 combination 3 is 10. We'll have y squared. 3 to the 3rd is, so 10 times 27 is 270 y squared. That's my next term. And it just continues. You'll have 5y, 3 to the 4th is, so 81 times 5 is 405 y. And now my last term is going to be 1 y to the 0 power, which is, and then 3 to the 5th is 243. Which I know that's Wednesday because of course I'm using blue pen on purplish background. And there is your expansion. Y'all remember this? Alright. You should be able to do this by hand because it could very well be in the non-calculator portion of the IB exam.
How do you get 10y squared?
10y squared. This part right here. Okay, so 5 combination 3 is basically 5 factorial all over 3 factorial times 2 factorial. So 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 times 1. Those cancel. So you have 20 over 2, which is 10.
What's the highest you could go?
Not calculated. Man, they can go as high as they want to, and just actually find one specific term.
85.
So they would never ask you to do a whole
They named the term by the expert.
But they do like
85 over 35.
That'd be
Depending on how many parts, that could definitely be
Want you guys to try this one on your own.
where does this class go?
Like you come to this class and then it's over. Like I can always look forward to math class being over quickly because it always does. I don't know how it works. Like we do one problem and then the class is over.
Because it takes forever to do a problem.
Like we're learning the lesson and then the class is over.
Yeah, I don't want. It always goes like, the final answer, it always goes, my name is first.
Yeah, you work for 5 years.
If someone
We're
had-
gonna get
if someone had
just
all these
columns.
reasons, and they grab
What
it,
else
like,
then?
I'd be here.
So you guys had this set up with pluses in between? Can't go that way or something be like two different lines here. So when I multiply this, or do the combination 4 to the 0, 4 combination 0, those are just the coefficients, 6, of my Pascal's triangle. Then 3a to the 4th is an 81a to the 4th. And then negative 2b to the 0 is just 1. Over here, 3a to the 3rd is 27a cubed. And then we have a negative 2b, because that's being raised to the first power. 6a squared, and a positive 4b squared. Where's the positive coming from?
It's a 9 is all.
It's 9.
Sorry, that is a 9.
I was like, no, it is.
Oh my God.
And that negative 2b turns into a positive 4b squared, because when you square a negative, it becomes positive. Down here, you'll have 3a, and then you'll have a negative 8b to the 3rd, because whenever you cube a negative number, it still stays negative. So there you go.
And
That's
then you
your
put it all together.
And then you put it all together, so we'll go diagonally. But it basically would be 81a to the 4th minus, let's see, 216, a to the 3rd b, plus 288, a to the 2nd, b to the 2nd. You should notice that your first variable is decreasing, your second variable is increasing in exponents, minus 96, a, b to the 3rd, and then 16, b to the 4th. And that will be your final answer.
Oh, yeah.
Yeah, I got 216.
216? Okay.
I had 12
I was gonna say, 54 times 4.
I
Yeah.
have to one body in my mind.
Yeah, I was putting on it.
There we go. Now remember this? Oh, we haven't forgotten.
You just had to find one thing
Bell.
about this.
Alright, here's one, okay? Here's one. It says find the x cubed term in the expansion of 4x squared minus 1 to the 9th, okay? They're only looking for one specific term. So in this case, we want the x to the 3rd term, which means that first term has to be raised to the 3rd in order for you to get the x cubed.
The other part is to the 6.
Which means the second term is going to be raised to the 6, because remember, the exponents need to add to give you your n. So if we have 3 here, then we'll have 6 for our last term.
It's right there. It is not a coupon.
As for your combinations, you always know the first number in your combination is a 9, or it's whatever n is. And then r is going to be what? You think?
3.
It's going to be 3. It's going to be that first exponent. So then to figure out what that term is, you're going to do 9 combination 3, 4x to the 3rd power, which would be 64x to the 3rd. And then negative 1 to the 6th power is a positive 1. What's that number? What's 9 combination 3? Use your calculator. And then let's multiply our coefficients together to get
Big number.
say it. 53, 76, x to the 3rd, and that would be our x to the 3rd term.
Didn't they ask the coefficient of when?
That's what it's doing.
It's easy to remember. Wait, no, what is the thing where you do like n minus 1?
Alright, so that one is goes like this. It says in the expansion of 2x plus 1 raised to the n, the coefficient of x to the third is 80. That term is 80. We have to find the value of n. So this one's a little bit different. You have to work a little backwards because we know that our x to the third term, that coefficient's 80. So that means for our combination, n is the top, 3 is the bottom, because we're looking for our x to the third term, that specific coefficient, which means that 1 would have to be raised to what power?
It adds up
So
to.
it doesn't matter.
It would be n minus 3 is whatever,
Yeah, adds up to n.
whatever n is, you would subtract 3 from it. But 1 raised to anything is just 1. So that's a little bit nicer. So we have n, combination 3, 8x to the third, that's just 1, equals 80 x to the third. Everyone okay up to here?
This is easy.
Wait, where did you get ABX from?
They
That's
gave
the
us,
problem.
it gives a coefficient.
The coefficient of the x to the third term. So we know that 80 x to the third is one of our terms.
So n over 3 is
So n over 3 is, how'd you get what?
And because you don't
Right.
So, oh, equals 10, okay.
10.
So yes, we can divide both sides by an 8x to the third. So we have n combination 3 has to equal 10. So we use our, formula of basically n times n minus 1 times n minus 2, all right? All over 3 factorial, or 3 times 2 times 1, times n minus r. So that's an n minus 3 times an n minus 4, so on and so forth. You guys follow along?
Yes.
All I'm doing is plugging this into the formula. N factorial, r factorial, n minus r factorial.
Wait, what is that above the
3.
3 times 2?
That was an error. I didn't keep going on that one. So it should be a n. Change back my pen. So it's gonna be an n minus 3, n minus 4. It just keeps on going. Down here, the bottom part does the same thing. And it keeps on going because we don't know what n is. And all of that equals 10. And what actually happens is things are going to cancel out. The n minus 3, n minus 4, n minus 5 cancels out with the n minus 3, n minus 4 at the top. So basically we'll have n times n minus 1 times n minus 2 all over 6 equals 10. And what that basically turns into is something that we can actually solve using old school algebra.
So how would you do it? That's a lot.
So this be n squared minus 3n plus 2 equals 60. I multiply both sides by 6 and I went ahead and folded the inside. So then that'd be n cubed minus 3n squared plus 2n equals 60. You can factor out an n. Well, actually, you wouldn't be able to factor this out because you can't set it equal to 60. So this one would have to be a calculator problem
When you graph it.
where you graph it. y1,
Um,
y2, and you get your answer.
I think it would be easier to select.